Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Todd. And thank you for joining us for SAT ACT Prep. So this week we're going to be talking about operations with numbers in between 0 and 1. A lot of people think that numbers less than 0 or negative numbers are the really weird values in math. And they certainly do have opposite effects, or in certain situations they have opposite effects, especially graphically. We're flipping something around the x-axis or rotating something to a certain value, and also in trigonometry when you're talking about angles. But the really weird stuff actually happens between 0 and 1. And so this week, to kind of as a caveat onto the last lessons, we've been talking about a lot of rooting and exponentiation, or raising things to powers. We've been talking about the rules of exponents, talking about solving things conceptually and rationalizing the denominator when the denominator has a radical in it. We talked about radical operations. So this is going to fit in line with all of that in the way that numbers between 0 and 1 have opposite effects, particularly when it comes to multiplication, division, exponentiation, and rooting. Not so much with addition and subtraction, because addition and subtraction involve finite values being combined or taken away from other values. Addition is the combination of groups, and those groups don't have to have any relationship with each other. Likewise, subtraction is the reduction of one group by another group's value. And those two individual values don't have to have any semblance with one another. Whereas with multiplication and division, that's the projection of one value over another, or the division of one value into equal groups, or I should say, not use the word in the definition, but the separation of one amount into equal groups. That's division. So the two values do have relationships to each other because they're kind of operating together to produce the outcome, whereas, and that might be really vague in general, but with addition and subtraction, I'm trying to get across that they're two finite values completely separate that don't have really any distinct relationship with one another, whereas multiplication, division, exponentiation, and rooting, we're going to see have some predictable outcomes when it comes when dealing with values in between 0 and 1. So let me go ahead and share my screen with you. And as always, because this is a live session, there is a little bit of a delay with the iPad, but I'll try and keep track of that. If there's any questions at any point, please feel free to let me know in the live chat function. Or if you're watching this recording, feel free to drop a comment below. Also, I started on my social media page posting question of the day video, not videos, question of the day pictures for reading, writing, and math on my Instagram, Facebook, and Twitter. So those are all listed in the description, so you should follow and friend me, and those are extra practice problems that you'd have access to. Okay, so the overarching theme for today, or this week rather, and let me just manipulate this camera so it's not in the way of everything. Resize it a little bit. Okay. So when solving statements conceptually, we can think of multiplying, dividing, exponentiating, or rooting by numbers between 0 and 1 as having the opposite mathematical outcomes when compared to numbers greater than positive 1. Sorry, there should be no occur there. When compared to numbers greater than positive 1. This is true for multiplication, division, rooting, and exponentiation, or raising a value to an exponent or power, by a number between 0 and positive 1. And this is because a lot of times in SAT questions, they're going to ask you what is the effect, did the value overall increase or decrease? So when multiplying by a number in between 0 and 1, it's going to have the opposite effect as if multiplying by a number greater than 1. It can get a little bit hazy, a little bit tricky when you're talking about overall outcomes and you switch the order around. We know that multiplication is commutative, meaning that the order doesn't matter. Like 2 times 3 is the same thing as 3 times 2. They're both equal to 6. However, if you're talking about, so for example, 4 times 1/2 is 2. 1/2 times 4 is still 2. But if you're talking about whether the starting value, the value that came first, is reduced or increased by the second value, that's where you have to be careful about the logic and you have to really think it through. So when you have a value greater than 1, if you have any number, any value really, if you have, let's stick with the value greater than 1, let's take 4, and you multiply it by a number in between 0 and 1, like 1/2, the value is going to go down. Normally, because 4 times 1/2 is 2. Normally, when you multiply, though, you would expect the number to go up. If we were multiplying by a number greater than 1, we would expect that the number, the outcome, would be greater than both of the two individual values, or at least greater than the starting value itself. But we're going to see that the opposite effect occurs. But I just wanted to put a disclaimer out there because the SAT and ACT questions are very logic-based, so you do have to be careful because that was not true. That's what we're saying in the second statement. This is not true for multiplying, dividing, exponentiating, and rooting a number between 0 and 1 by a number greater than 1 because of the logical connections that we will investigate in the problems below. So if you're starting, so if you're starting with a number greater than 1 and you're multiplying it by a number in between 0 and 1, it's going to go down where you would normally expect multiplication to increase the overall result. If you were multiplying by a number greater than 1, like I said, it's going to go up. So we're going to go through, look at some charts here. We're going to draw some charts out. So let's just take, for example, x is equal to 4. And let's look at x squared versus x versus the square root of x. And we're going to have two possible values. So let's say if we're testing x is equal to 4 and a number in between 0 and 1, x is equal to 1/4. Let's make it a fraction. So normally when we square a value, 4 squared is the same thing as 4 times 4, which is 16. So we would expect this value to go up. However, when we square 1/4, and actually let me write that all out. So 4 squared is equal to 16, therefore we increased. But with a number in between 0 and 1, like 1/4, when we square 1/4, that's the same thing as 1/4 times 1/4. 1 times 1 is 1, 4 times 4 is 16, so we're going to have 1/16. Notice 1/16 is a smaller number than 1/4. So the overall result was that we decreased. So you can see that the relationship here is inverse. It's they're going in opposite directions. X is just equal to x, so x is equal to 4, x is equal to 1/4. Now if we take the square root, if we take the square root of 4, we get positive 2. If we evaluate the square root of positive 4, we get positive 2. Notice to go from 4 to positive 2 is an overall decrease. If we square root 1/4, we can use the distributive property here, and that's the same thing as the square root of 1 over the square root of 4, which would be 1/2. Notice that 1/2 is a larger number than 1/4, so the overall result is that we went up. So with numbers in between 0 and 1, we're going to have the opposite effect than if they were greater than 1. So we can use this rule with some rather tricky SAT and ACT questions when we're trying to solve conceptually. Remember, we always want to solve conceptually whenever possible. It's usually quicker. But as a fallback method, we can always use substitution. So the substitution method is just like this. When we pick values within the acceptable domain or within the context of the domain listed in the question, and then we plug those values in and evaluate whether they're true or false. But if we're able to understand the relationships that are inherent in the expressions, then oftentimes we can just think a lot of these problems out. I also just wanted to back up, and I was thinking about this. I think that this is a typo here that I just wanted to clarify. by rooting a number between 0 and 1 by a number. Yeah, see, I'm sorry, I wanted to clear this up. So, this statement, this is not true for multiplying, dividing, exponentiating, and rooting a number between 0 and by a number greater than 1. Oh, no, I'm sorry. So the point here, I just wanted to make sure this was correct because I didn't want to confuse anyone. The point that I'm trying to make here is that if we take 1/2 and multiply it by a number greater than 1, the result, if we're starting off with 1/2, if we're trying to investigate what happens to the number 1/2, 1/2 times 4 is going to give us 2. So the overall result is still increasing as we would expect by multiplying by a number greater than 1. So you just have to think, the question can be asking about the relationships involved, it can be asking about the overall outcome from the starting point, or it can be asking you just to evaluate mathematically for like a missing value or something like that. But I just want to be clear that this is where the test makers can take a lot of leniency in the tricky nature of, or the conceptual nature of the problem, of these types of problems. So if we're thinking about what happens to something, if you're multiplying by a number greater than 1, the normal thing will occur. If it's multiplying, it's going to increase. If it's dividing, then we're going to decrease. If you're multiplying by a number or dividing by a number in between 0 and 1, then the opposite is going to occur than you would normally expect. So you can kind of think to yourself, what would I normally expect? And then flip that logic around to understand whether the overall result is an increase or a decrease. And that saves a lot of time in most situations. If there's any questions about that, please let me know. I hope that wasn't too confusing. I just wanted to make sure that I got that right. But yeah, just let me know. I also here, if just a few examples. So if A is greater than 1 and B is in between 0 and 1, so I'm basically saying, if A is a positive number, basically, and technically, let's say A greater than 1 instead of 0, just to be absolutely distinct. So if we have some number that's greater than 1 and we have another number B that's in between 0 and 1, then A is decreased when multiplied by B, because B is between 0 and 1, but B is increased as we would normally expect when multiplied by A, because A is greater than 1. So if A is greater, the same type of scenario, A is increased by B because B is between 0 and 1, but B is decreased as normal when divided by A because A is greater than 1. So whenever something is being multiplied again by something greater than 1, the normal, what you would normally expect, or divided by something greater than 1, what you normally expect to occur is multiplication would increase and division would decrease. But if you're multiplying by a number between 0 and 1, or you're dividing by a number between 0 and 1, the opposite is going to occur. When you multiply by a number between 0 and 1, it's going to go down. When you divide by a number between 0 and 1, it's going to go up. And let's just go ahead, if there's any questions on that, but I don't want to belabor the point because I think I explained that, talked a little bit more than I usually do before. But let's just go ahead and look at a few problems, and I think that is always the best explanation, is just going through some examples here. So number 1, if A and B are greater than 0 and less than positive 1, which of the following statements is or are true? A times B is less than A times B over B is greater than A, 1 over A plus 1 over B is greater than A plus B, and then you have statements, the answer selection A is statements 1 and 2, B is 1 and 3, C is 2 and 3, and answer selection D is statements 1, 2, and 3. So I'll give you 3 minutes, and then I'll give you the answer, and we'll just keep going through a few examples. Okay, so if a and b are greater than 0 and less than positive 1, that means that we could pick these as being fractions between 0 and 1 and evaluate and see which statements are true and select those statements in the true statements as the answer. But we always want to try and solve conceptually, but we could, as a fallback method, maybe say that a is equal to 1/2 and b is equal to 3/4. That satisfies, those are both within the domain that they're listed as a and b being greater than 0 and less than positive 1. But let's also think about these conceptually, like I said. A times b, we have a number in between 0 and 1 times another number in between 0 and 1. A times b necessarily must always be smaller than just a, because both fractions are going to decrease the other. Right? If we multiply any value times a number in between 0 and 1, we'll decrease that value. And to prove it, if we had 1/2 times 3/4, that's going to be 3/8. 3/8 is less than 1/2, and it's less than 3/4. So statement 1 is true. And I'm sorry, give me 1 second. I forgot to turn the fish tank's bubbles down. So sorry if that was really loud this whole time. I apologize. Number 2 says a times b over b is greater than a. So again, let's look at the relationships here. If we have a times b, that's going to be a smaller result. But divided by b is actually going to increase the overall result. So 2 is a good statement to actually go in and test. So if we can assigned a to be 1/2 and b to be 3/4, then we'd have 1/2 times 3/4 over 3/4. So if we evaluate that, 1/2 times 3/4 is going to be 3/8 over 3/4. When we have a fraction divided by a fraction, we leave the numerator alone, change the operation from division to multiplication, and take the reciprocal of the denominator. Or in other words, flip the numerator and denominator around for the fraction in the denominator. 3 times 4 is 12. 8 times 3 is 24. So this is going to simplify down into 1/2. And a is 1/2, so 2 is not true, because 1/2 is not 1/2 is not greater than 1/2. And number 3, we have 1 over a plus 1 over b is greater than a plus b. So if we think about this conceptually, 1 over a fraction, normally if we take 1 over something, like if we start with 4 and then put it over 1, that's also another way of saying taking the inverse of 4. But if we were to start with 4 and we put it under 1, that turns it into 1/4. We would normally expect that to decrease the overall value. With a value in between 0 and 1, that's actually going to increase, because if we look at 1 over 1/2, I could rewrite that 1 in the numerator as just being 1 over 1 divided by 1/2. Remember, you can always rewrite something as a fraction by just putting it over 1. And if you're dividing by a fraction, you want to have it everything in terms of a fraction. Then we keep the numerator the same, change the operation from division to multiplication, and take the reciprocal of the denominator. So this is going to be 1 over 1 times 2 over 1. So notice that 1 over 1/2 actually turns into 2. It increases. So statement 3, I'll do this in another color. Statement 3, 1 over a is going to increase, 1 over b is going to increase. So conceptually, I already know that statement 3 is true, because we have the sum of two values that are increasing are greater than the original sum. That has to be true if the values are increasing, if 1 over a and 1 over b produce larger values, which would occur if a and b are in between 0 and 1. But just to prove it, let's substitute in 1/2, 1 over 1/2, and 1 over 3/4. First, I'm going to rewrite the numerator as just 1 over 1. So I have 1 over 1 divided by 1/2 plus 1 over 1 divided by 3/4. This allows me to keep the numerators the same and multiply by the reciprocal of the denominator. I should say denominators. So I have 1 over 1 times 2 over 1 plus 1 over 1 times 4 over 3. So that's going to turn into 2 over 1 plus 4 over 3. If I were to think about those as decimals, 2 over 1 is 2, and 4 over 3 is going to be 3.3 bar, or 3.33333 repeating. So I already know that's greater than 1, and both these fractions would at most be a little bit over 1. They couldn't be greater than 2 because neither of them can be greater than 1 individually, so their maximum sum would be less than 2. So this is already greater than 2. But just to remind you about how to deal with fractions, we need common denominators here. Remember, we went through the operations with radicals, and we remembered the operations or the rules with radicals by remembering our rules of fractions. In order to add or subtract fractions, we need common denominators. Just like when we need to add or subtract radicals, we need common radicants. Once we have common denominators, or once we have common radicants, we keep the denominator or keep the radicant, add or subtract the numerators. And then with the radicals, keep the radicand, add or subtract the coefficients. So here we need to get these denominators equal. I can do that by multiplying this first value by 3 over 3, because the least common multiple between 1 and 3 is 3. The second fraction already has a denominator of 3, so I only need to multiply or manipulate. I only need to manipulate the first fraction. As long as I do the same thing to the numerator as I do to the denominator, as long as I do the same thing to the left side of an equation as I do to the right side of an equation, you can practically do almost anything that you want in math, except for a few things, like you can't divide by 0 or a few other things. But in general, you can do anything as long as you balance it. So this is completely valid. Notice that 3 over 3 also, what is 3 divided by 3? That's 1. 1 times anything is that same something, so that proves also that you're not actually changing the value here. You're just manipulating the proportions between the numerator and denominator. 3 times 2 is 6, 3 times 1 is 3, so we're going to have 6 over 3 plus 4 over 3. Once we have common denominators, we keep the denominator, add or subtract the numerators, so this is going to be 10 over 3. 10 over 3 is definitely greater than a plus b, because since neither one of them can be greater than 1, then their sum must be less than 2, and 10 over 3 is definitely greater than 2. It's 3.33. So statement 2 is true, and so our answer here is going to be 1 and 3 only, which is answer selection B. If you have any questions, then please let me know. Otherwise, take a look at number 2. I'm going to give you 3 minutes, and then I'll give you the solution. I'm sorry, I didn't start the time yet. I want to read the question for everyone. If A and B, or for the recording rather, if A and B are greater than 0 and less than positive 1, then which of the following statements is or are true? Statement 1 says A over B is less than A. Statement 2 says B over AB is greater than A. Statement 3 says A squared is greater than A cubed. And answer selection A is statements 1 and 2. B is statements 1 and 3. C is statements 2 and 3. And D is statements 1, 2, and 3. Okay, 3 minutes. Thank you. Okay, so first of all, I wanted to just point out a little bit of a testing strategy. Notice that statements 2 and 3 are much more complex than, I'm sorry, not 2 and 3. Statements 1 and 2, I'm sorry. Statements 1 and 2, do you see how much more complex statements 1 and 2 are than 3? 3 is pretty straightforward. With these multi-statement questions, these are really great opportunities to use an elimination strategy, because usually if you can prove one statement to be true or false, you can eliminate more than one answer selection, because oftentimes more than one answer selection contains one of the statement numbers. So let's go ahead and look at 3 first. Statement 3 says a squared is greater than a cubed. So a has to be in between 0 and 1. Remember that with exponentiation, the opposite is going to occur than if the number were greater than 1. So normally, if we exponentiated something to the 2nd degree or to the 3rd degree, we would expect that value to increase. Here it's going to decrease. And if we cube it rather than square it, cubing it is going to make it decrease even more. So, for example, if we think of a number and what would happen if we let x be equal to 4 versus x being equal to 1/4. So let's look at x squared versus x cubed. So x squared, normally if it was greater than 1, x squared would be 4 squared or 16. So this would normally be an increase. 4 cubed would give us 64. So you notice that it would increase even more than if we just squared it. So I'm going to put 1 arrow sign for squared and 2 upward arrow signs for cubed, because you can see that cubing it obviously increases it more. The opposite is true though for numbers in between 0 and 1. If we squared 1/4, that's going to become 1/16. That's a decrease. If we cubed 1/4, that would become 1/64. That's even more of a decrease. So I'm going to put 2 down arrows for x cubed and 1 down arrow for x squared. So you can see that a cubed is going to, they're both going to decrease overall, but a cubed is going to be much less than a squared because the number is in between 0 and 1. So statement 3 is true. A squared definitely is greater than a cubed. So if 3 has to be true, then we know that a is not true. For the other values, for the other statements, it might be helpful to plug in some numbers because it is a little bit relative. So let's just define, identify our domain to be in between 0 and 1. So let's just pick a to be 1/2. And let's pick b to be 3/4. So a over b, that's going to be 1/2 divided by 3/4. That's equal to 1/2 times 4/3. And that's equal to 4/6, which is the same thing as 2/3. So is 2/3, is 2/3 greater than a, which is less than a, which is 1/2. So 2/3 is not less than 1/2. 2/3 is greater than 1/2. So statement 1 is false. And so notice that you know that this answer has to be answer selection C now, because there is no answer selection that has only one statement. Sorry, Dr. Todd is dreaming. Dr. Todd, you dreaming? Let's go ahead and look at statement 2. So b would be 3/4. A times b is 1/2 times 3/4. So that's going to be 3/4 over 3/8. That's the same thing as 3/4 times 8/3. So that's going to be 24 over 12, which is 2. And 2 is definitely greater than 1/2, so statement 2 is also true. So your answer here is going to be statements 2 and 3 only, and that's answer selection C. If you have any questions, then please let me know. I'll give you 3 minutes. Please look at number 3. It reads, if A and B are greater than 0 and less than +1, then which of the following statements is or are true? Statement 1, B over A times B is less than A. Statement 2, B over A times B is greater than B. Statement 3, A to the 5th power is less than A to the 3rd power. And the answer selections are A, statements 1 and 2 only, B, statements 1 and 3 only, C, statements 2 and 3 only, D, statements 1, 2, and 3. I'll give you 3 minutes, and then I'll give you the solution. Okay, so for statements 1 and 2, always be on the lookout for a shortcut or some type of simplification process. Notice that you have the same thing in the numerator and denominator. You have a b in the numerator and you have a b in the denominator, and they're attached in the denominator through multiplication. When things are attached by addition or subtraction, they're considered binomials, and you have to be able to pull the same factor out of both in order to eliminate between the numerator and denominator in the fraction. However, when they're attached by multiplication or division, you can go right at them because it goes back to that relationship between multiplication and division being scalar projections. of a value, so there is an inherent relationship between the numbers and the result, whereas addition and subtraction is just finite addition or grouping or taking away from, where the values don't have that inherent relationship. But we can simplify here. Notice there's a b in both the numerator and denominator. So I'm going to rewrite this as 1 over a is less than a. And I'm going to rewrite the second one as 1 over a is greater than b. Remember that a and b are both fractions in between 0 and 1. What happens to a number when we normally, so if we have like x is equal to 4 versus x is equal to 1/4 again. Let's look at what happens when we do 1 over x. If we do 1 over x, then I'm going to get 1/4. We normally expect that to decrease. Taking the reciprocal or taking the inverse of a value is normally going to decrease a value that's greater than 1. But a number in between 0 and 1, we're going to have 1 over 1/4. I can rewrite that as 1 over 1 over 1/4. And notice I can rewrite that as 1 over 1 times 4 over 1. So that turns into 4. That's an increase. So the opposite effect occurs when the value is in between 0 and 1. So 1 over a is going to increase and be larger than a. So statement A is true. 1 over a is not going to be, statement 1 is false. 1 over a is not going to be less than a. It's going to be greater than a because it's going to increase. Statement 2, 1 over a is greater than b. We suspect that to be true, that because b has to be in between 0 and 1. So yeah, that is true, because even the highest decimal, so for example, if a was like 0.999, 1 over 0.999 is still going to be greater than 1. And that's a principle or a relationship that you should become familiar with. Notice that 1 divided by 0.99 is going to be 1.001. Right over the edge of 1. Notice that 1 divided by 0.001, a very, very small number, is going to be very, very large. That's going to be 10,000. So you can see the relationship there. When you divide by a smaller and smaller number, your result in between 0 and 1, your result is going to be very large. So when you divide by a very small number in between 0 and 1, the result is very large. When you divide by a relatively large number between 0 and 1, meaning closer to 1, your value is still going to be greater than 1. So it has to be greater than b, meaning statement 2 is true, because b has to be between 0 and 1 by definition. And then we have statement 3. So we know that 1 is false. So we know that a, b, and d, just by knowing 1 is false, we know that the answer is c. So we know that 3 has to be true as well. And it is true because a to the 5th power, if we're talking about a number in between 0 and 1, if we exponentiate it to a higher power, the opposite effect is going to occur. Normally when we exponentiate a number greater than 1, we would expect the result to be larger than the number itself. So the opposite is going to be true when we exponentiate a number in between 0 and 1. It's going to be smaller than the number we started with. So a to the 5th power is definitely less than a to the 3rd power. And they're both going to be less than a itself, but a to the 5th is going to be much smaller than a to the 3rd, if a, again, is in between 0 and 1. So our answer here is 2 and 3 only. If you have any questions, please let me know. Otherwise, let's look at practice set B. So those were 3 very similar type problems. Now we're going to go into 3 other similar related problems. So practice set B, number 1. If 0 is less than x, which is less than 1, then which of the following statements are in ascending order? Statement 1 says x to the 5th, comma, x to the 3rd, comma, x to the negative 2 power. Statement 2 says x to the 3rd, x comma x to the negative 2 power comma x to the 5th. And statement 3 says x to the 3rd comma x to the 5th comma x to the negative 2 power. Answer selection A is none, B is statement 1 only, C is statement 2 only, and D is statement 3 only. I'll give you 3 minutes and then I'll give you the solution. Okay, so if x is in between 0 and 1 as the domain interval 0 less than x less than 1 tells us, we could pick x to be some value in between that interval, let's say 1/2, or if you want to work with a decimal, you can say 0.5. You could plug those in and see which are in the correct order. Remember, notice that ascending means least to greatest. Or in other words, going up. Descending would be greatest to least, or going down, so vocab matters here, you got to get in the right order. But we also can think about this conceptually. So normally, let's just think about, let's let x be equal to either 2 or a number in between 0 and 1, let's say 1/2. Let's look at x to the 5th, let's look at x to the 3rd, let's look at x to the negative 2. Normally, if x were equal to 2, then 2 to the 5th power is 32. So we went up. 2 to the 3rd power is 8. We also went up, but 2 to the 5th really went up. So I'm going to put, and I'm going to use a different color here, I'm going to put 2 arrows for x to the 5th, and I'm going to put 1 arrow for x to the third. If we look at what happens to 1/2, this would turn into 1 over 32. X to the fifth, 1/2 to the 1/2 to the fifth power is 1 over 32. 1/2 to the third power would be 1 over 8. Notice that 1 over 8, or x to the third power, when x is in between 0 and 1, is a decrease. But when x is in between 0 and 1 and we raise it to the fifth power, that is a super decrease. Normally, with x to the negative 2, notice x to the negative 2 power is the same thing as 1 over x to the positive 2 power. Remember our conversion. So we just put 1 over the positive version of the exponent. So 1 over x squared would be 1 over 4. Notice that that is a decrease. But if the number is in between 0 and 1, like 1/2, then we'd have 1 over 1/2 squared. That's going to be 1 over 1/4, which is the same thing as 1 over 1 over 1/4, which turns into 1 over 1 times 4 over 1, which would be 4. So this guy increases. You see that the opposite is occurring than what would normally occur with a value greater than positive 1. So we can see that with a value in between 0 and 1, if we're going in ascending order, least to greatest, x to the fifth is going to be the least, followed by x to the third, because that's a decrease, and then x to the negative 2, because that was an overall increase. So your answer here is statement 1 only, and that's answer selection B. If you have any questions, then please let me know. Otherwise, please take a look at number 2. I'll give you 3 minutes, and then I'll give you the solution. I apologize. I keep on forgetting to read the question. My apologies. I paused the time. Let me just read this for the record, for the recording. If 0 is less than x is less than 1, then which of the following statements are in ascending order? Statement 1, x to the negative fifth power, comma, x to the negative third power, comma, x to the negative second power. Statement 2 is x to the negative second power, comma, x to the negative third power, comma, x to the negative fifth power. Statement 3 is x to the negative third power, comma, x to the negative fifth power, comma, x to the negative second power. Answer selection A is none, B is statement 1 only, C is statement 2 only, and D is statement 3 only. I'll reset the time, and you have 3 minutes. Okay, so if we got stuck on this problem, you could definitely just pick a value that applies or that is suitable for x, meaning that it's in between 0 and 1. So for example, maybe 1/2. And then just evaluate to see which is the smallest and which is the greatest. You want to go in ascending order, so we're going up. That means you want least to greatest. However, we want to get to a point where we're solving these problems conceptually. Think to yourself what would happen if the value were greater than 1, let's say like 2. So x to the negative fifth, that would be 1 over 2 to the fifth. That would be 1 over 32. That would be an overall decrease. X to the negative third, that would be 1 over 2 to the third power. That would be 1 over 8. That would be an overall decrease. And if we were talking about x to the negative 2 power, that would be 1 over 2 squared. That would be 1 to the fourth. So they're all a decrease, but notice that as we exponentiate higher, we're decreasing more. So if x were equal to a number in between 0 and 1, the opposite is going to be true. X to the negative fifth is going to be the most increasing. X to the negative third is going to go next. And then x to the negative 2 will have the least overall increased result. So the greatest value, well, we're going least to greatest. So the smallest value is x to the negative 2, then x to the negative 3, then x to the negative 5. And that's statement 2. So your answer here is going to be C, statement 2 only, because going in ascending order, we would have x to the negative 2 power, comma, x to the negative 3 power, comma, x to the negative 5 power. If you have any questions, please let me know. If not, please take a look at question number 3. Question 3 reads, oh, why did that cut off? I'm sorry. Take that out of there. That should be just if 0 is less than x and less than 1, positive 1, then which of the following statements is or are in ascending order? We have statement 1 is x to the negative fifth power, x to the negative third power, x to the negative 2 power. I'm sorry, let me just check here. Oh no, is this a... Oh, I'm sorry, it duplicated over. I'm sorry. Well, I'm going to skip over that because it's skipped over there. Let's look at practice set C. Sorry. So if negative 1 is less than x, which is less than 0, then which of the following is or are in descending order? We have x squared, x cubed, x to the fifth. That's statement 1. Statement 2 is x cubed, x to the fifth, x squared. Statement 3 is x to the fifth, x cubed, x squared. And the answer selections are none, statement 1 only, statement 2 only, or D, statement 3 only. So I'll give you 3 minutes for this question, and then we'll go through the solution. My apologies. Okay, this problem is actually a little bit tricky because our domain now is negative. We're talking about -1 less than x less than 0. So we're talking about numbers that are between 0 and -1, and obviously negative as well. So I'm going to give you a few extra minutes after I give you a few hints here. First of all, any negative number raised to an even power, any even power, so if you raise it to the second power, if you square it, if you raise it to the fourth power, the sixth power, the eighth power, the 10th power, so on and so forth, an even exponent will eliminate the negativity in the value. But an odd exponent will retain the negativity. So anything raised to the third power or to the fifth power, if it's a negative number, it's going to remain negative. If it's raised to an even power, it's going to actually turn positive. So that's a consideration to make. Because that will change the overall effect, obviously, because all negative numbers are less than all positive numbers. But other than that negative, the negative characteristic that you definitely do need to consider, the relationships between the numbers between -1 and 0 are the same from a magnitude standpoint as those between 0 and +1. So I'm going to give you 2 more minutes and then I'll give you the answer. Okay, so if -1 is less than x, which is less than 0, so maybe x would be equal to -1/2. If you wanted to substitute in and solve, that would be one method, and that might be preferred here just because these are quite tricky. Remember that when something reduces, when we multiply by a number in between 0 and 1 and we expect that to reduce the overall value, reducing it means necessarily getting closer to 0 on the number line. But getting closer to 0 on the number line, if the values are negative, means that it's actually a larger value. So that's where it gets a little bit counterintuitive. So if you are decreasing the magnitude, meaning the size of the number, the distance from 0 on a number line, if you decrease the magnitude of a negative number, that's actually increasing the value because smaller negative values are larger, in fact, are larger values than larger magnitude negative values. For example, -1 is a larger number than -100, right? So the conception here gets a little bit tricky. And then remember that even exponents are going to eliminate the negativity, whereas odd exponents are going to retain it. So if we had negative 1 squared, negative 1 squared, negative 1 half squared, not negative 1. Negative 1 half squared would be negative 1 half times negative 1 half. Notice that a negative times a negative cancel out, and so then we would have positive 1/4. If we had negative 1 half cubed, however, that's going to be negative 1 half times negative 1 half times negative 1 half. So the first two values would turn into the positive 4 that we found before. However, then we have one more negative 1 half to multiply by. So that's going to turn into negative 1/8. And then finally, negative 1 half raised to the 5th power. Because it's an odd power, it's going to retain the negativity, so that it's going to be 1 over 2 to the 5th is 32. So that's going to be negative 1 over 32. Now you have to think about this. Negative 1 over 32 is closer to 0 than negative 1/8. Negative 1/8, even though it has a larger magnitude, right? 1/8 we normally would think of as being a larger number than 1/32. However, we're talking about them being negative now. So negative 1/32 is actually a larger number than negative 1/8. So the smallest value here is going to be negative 1/8, then negative 1 over 32, and then positive 1/4. So negative 1/8, that was x to the 3rd power. Negative 1/32, that was x to the 5th power. And positive 1/4, that was x squared. So our answer here is going to be statement 2 only, which is answer selection C. If you have any questions, please let me know. Let's look at question number 2, and this will be the last question for today. If negative 1 is less than x, which is less than 0, then which of the following is or are in descending order? Statement 1 says 9 to the x power, comma, 16 to the x power, comma, 64 to the x power. Statement 2 says 16 to the x power, comma, 64 to the x power, comma, 9 to the x power. Statement 3 is 64 to the x power, comma, 16 to the x power, comma, 9 to the x power. And answer selections A through D. A is none, D is statement 1 only, C is statement 2 only, and D is statement 3 only. I'll give you 3 minutes, and then I'll give you the solution. Okay, so if x is in between -1 and 0, and then notice that x is an exponent here. Let's take x to be a little bit as most common of an exponent as possible. Remember, let's pick x to be -1/2. And this could occur with anything, with any value in between. You could have used, is what I'm trying to say, you could have used any value in between -1 and 0. But it's a little bit tricky to think about. Notice though that anything x to the 1/2 power is the same thing as the square root of x. Remember your rules of exponents when translating between fractional exponents and radicals. So x to the -1/2 power, first, we can think about this as first just 1 over x to the +1/2 power, and so that's really just 1 over the square root of x. So if we were to assign x to be equal to -1/2, then all of these values are really just 1 over the square root of whatever that value is. I should have, instead of using x, I'm sorry. So if x is equal to 1/2, because I already used x, I would have 2 x's there. So if we had a to the -1/2 power, that's equal to 1 over a to the +1/2 power, which is just 1 over the square root of a, where a is equal to 9 or 16 or 64. So if a was equal to 9, we would have 1 over the square root of 9. That would be 1/3. If a were equal to 16, we'd have 1 over the square root of 16. That's 1/4. If we have a is equal to 64, then we would have 1 over the square root of 64. That's 1/8. So we have 1/3, 1/4, 1/8, and we're talking about, we want to put these in descending order, so that's greatest to least. So the greatest here is going to be 1/3, followed by 1/4, and the least would be 1/8. So we're going to have statement 1, 9 to the x power, comma 16 to the x power, comma 64 to the x power, which is answer selection B, statement 1 only. If you have any questions at all on anything that we've done today, then please let me know. If you find these videos helpful, then please like and subscribe to my channel and share it with any friends or classmates that you have. I hope you guys have a wonderful day. Otherwise, Tater Tot, do you want to say goodbye to everybody? Come on, you got to say everybody. You got to tell everybody bye. Come on, up. You do bye. You say bye to everybody. Come on. Oh, he doesn't want to do it. He said, come on, come on. Say bye. Good boy. Very good boy. All right, thank you guys very much. I hope you have a good day. I'll talk to you all tomorrow for a reading lesson, and Wednesday when we continue our conversation with numbers between 0 and 1. Bye.